Okay, well, so next we shall discuss about polarization by scattering. How polarization is going to take place by scattering process we will discuss. So this is the diagram we are using. So in order to explain polarization of light taking place, how the polarization takes place by scattering process. So these are unpolarized light. So here, and this is the molecule, and here these are the scattered light. So polarized light we are calling. So here in this diagram, when sunlight, so this is the source, when sunlight encounters molecules of Earth atmosphere, it gets scattered when sunlight is seen perpendicular to the direction of the incident. So it is found to be plane polarized. So from this diagram, so double arrow shows vibration in plane of paper and dot shows vibration perpendicular to the plane of the paper. So when sunlight is incident, so on molecules of Earth atmosphere, electron in molecular begins to vibrate in both directions. The electron vibrating parallel to the double direction cannot send energy towards the observer. So looking at 90 degree to the direction of the sunlight because of acceleration, direction has no transverse component. Light scattered by molecules in this direction has dot. It is polarized perpendicular to the plane. So this is the observer and this dot point is molecule. This is scattered light. We are calling that one as polarized, and this is unpolarized, is nothing but sunlight it is. So this is the diagram we are using in order to represent polarization by scattering process. So next we shall see how the polarization takes place by reflection. So in order to represent, this is the PQ is the surface and this is the incident ray and this is the reflected ray. So that passes through the analyzer. So this is UPL. So that we are going to represent by arrow mark here. And this is the angle, polarizing angle we are going to, this is the normal drawn to the surface. So let us see how the polarization takes place by the reflection process. So here, when unpolarized light is incident on the surface of transparent medium, light will get reflected and found to be partially polarized. So it is observed by analyzer. So this is the analyzer which is rotated about direction of reflected light. So intensity of reflected light varies between maximum value to minimum value, but it does not become zero. This suggests reflected light is partially polarized. So degree of polarization will depend upon angle of incidence gradually increases from 0 to polarizing angle also increases. At particular angle of incidence, the reflected light is completely plane polarized, so which is perpendicular to plane of incidence. So this angle is incident is called polarizing angle, or we can call that one as Brewster's angle. So how we are going to define Brewster's angle? So Brewster's angle is defined as, so that is the angle of incidence for which reflected light is completely plane polarized is called polarizing angle, or we can call that one as Brewster's angle. That is always represented by the symbol theta I, or you can represent this is polarizing angle is always represented as IP. So this is the process how the polarization is going to take place by reflection method, and how the polarization is going to take place by the scattering process. So next we shall discuss about Brewster's law. So what is the statement of Brewster's law and how we are going to derive that and how we are going to show that one we shall see. So here this is the diagram. So PQ is the plane. So here Mn is the normal drawn to PQ, and this is the incident ray and this is the refracted ray. So what is the statement of Brewster's law? So what it states is, So the statement is like this. So refractive index of the reflecting medium is equal to the tangent of the polarizing angle, and that is always represented by n is equal to tan theta p. So n is the refractive index of the reflecting medium and theta p. So in this it is the polarizing angle tan theta p. So from this diagram, so PQ is the refracting surface and this AO. So this AO that represents incident ray, and this OB is the refracted ray. So this is the reflected ray and OC is the refracted ray. So this is called refracted ray. This is refracted ray and this is reflected ray. So and this is the normal drawn to PQ, and R is this. R is nothing but angle of refraction, and this theta p is the, so that is polarizing angle. So this is nothing but polarizing angle, we are calling polarizing angle. So how we are going to explain this one? So we are considering the beam of unpolarized light. So that is incident at an angle theta p on surface of refracting medium PQ. At polarizing angle, the reflected ray and refracted ray are found to be 90 degrees. So this angle, if you measure, it looks like a 90 degree. So from this diagram, angle MOB. So MOB. So where it is? So this M, this is O, and this is B. So from this, so this angle we are going to find. MOB plus of NOC. N, this is O and this is C. So from this, so first this angle and NOC, this angle. So sum of these two is nothing but 90 degree. Angle MOB and angle NOC is equal to 90 degree. So MOB, this is nothing but polarizing angle theta p. NOC is substituted as R is equal to 90 degrees, kept as it is. So if we want R, so keep this one. So this becomes 90 minus of theta p polarizing angle. So we know from Sun's formula, Sun's law, refractive index is given by n is equal to sin theta p divided by sin theta r. So we consider this one as equation 2 and this is equation 1. So put equation this one in equation 2. So then we are getting n sin theta p divided by sin 90 minus of polarizing angle it becomes. So sin theta p is kept as it is. Sin of 90 minus of polarizing angle it becomes cos of polarizing angle theta p. So sin by cos, the function is tan into theta p. So polarizing angle. So this is given as n is equal to tan theta into p. So this is the proof of Brewster's law.